Great. Well, hello. My name's Kevin Quealy. Thank you for that introduction. That's much better than I deserved. I'm a graphics editor and reporter at the New York Times, and at a specific part of the New York Times called the Upshot. And I'm here today to talk about what we do there. Mostly I came here today, I'm really excited just because I like being around people like you. I want this to be useful for you. And I think that the number of people in this room was already greater than the number of people who will ever stream this on the internet. So to that end, if you have any questions, please feel free to interrupt me at any time. I want you to get something out of this. That's the only reason that I'm here. So you can think of it as more of a conversation. Like I said, I will not be upset if you interrupt me at any time, including right now. Most of the things I'm going to talk about today are 60-40 politics. Partly because, as you may know, we recently had a political election in this country, and that's the sort of thing that we've been thinking about and processing for recent weeks. But if you hate politics, and that's a totally defensible opinion to have, we have some examples to talk about other things that we do at the Times as well. Shall we begin? Anything before I get started? And you can hear me okay on the internet and the microphone? Okay, great. So I'm going to show you a picture of a person who is not my boss, but who started out as my boss when I started working. This is a picture of Steve Duenas. More accurate, this is a picture of Steve Duenas 10 years ago when this photograph was taken. He looks approximately 10 years older now, 10 to 30. And I think this is a useful picture to bring up just because I'm going to quote him from an article that he wrote 10 years ago, which was about what the New York Times graphics department does. And I think the sentence that I'm going to give you is obviously reductive about what it is that we do, but we have to start somewhere. So I edited this mildly because this is 10 years old. A group of journalists who research and create the diagrams, maps, and charts for the newspaper and the website. This is a quote from an article that it was like a talk to the newsroom sort of Q&A that we had published. And like I said, this is very reductive. It doesn't necessarily, you would never go from this definition directly to the kinds of work that we publish on the New York Times, but there still is helpful information in here. Certainly the number, 50. Depending on how you count, like anything, it sort of depends how you count, but there are dozens and dozens of people now at the New York Times who have sophisticated skills in either statistics, web development, information design, data analysis. What other assorted digital skills am I missing? Is that about it?
I don't know.
Document. Yeah, sure, that sort of thing. So this number is growing, and this is a good time to say we have more opportunities for people with the skills than we currently have applicants to fill them. So it has never been a better time for an unskilled 25-year-old to be hired at the New York Times, and we're very interested in increasing the number of people with these skills. But specifically, I think there's meaningful information in that we research and create them. So lots of the people on our desk, the first thing if you said what do you do, before if they would answer that they're a cartographer or that they're a data analyst, I think and hope that they would say that they are a journalist. First and foremost, we are journalists and reporters at the New York Times. The news is the product that we create, and that is, all of the skills are in service of the news. So we both research and create them. We're not the people who, we don't art stories. That's not how you get outstanding work, and that's not what we get up every day to do, is to draw pretty pictures around someone else's work. So a lot of times we'll get programmers and other kinds of people in here to say do you write the articles or do you make the charts? And the answer to that question is yes. It's not very helpful. We think about the entire product. And secondly, the sentence was a little bit more innovative 10 years ago than it is now, but we do it for the newspaper and the website. If Steve were answering this question today, he would probably say, we do it for your iPhone and for your desktop, and also for the print edition when time permits. So that means because of the necessities of our publication, we are increasingly skilled at, or giving at least our attention to designing things, information design on tiny devices, but we're also making things for desktop displays. We also do actually still put information graphics in the print edition, which is something that I'm sure exists on this campus somewhere. So after about 6 years on the Upshot, do you guys know who Nate Silver is? Have you heard of Nate Silver? It's no shame in not knowing who Nate Silver is. Do you have a question?
Oh, no.
Okay.
I saved my hand for a yes.
Okay. So the New York Times had licensed 538, which is his website, and then after Nate left the Times and he took 538 with him, the Times decided to invest in that same style of analytical journalism. And it was headed by a guy named David Leonhardt, and he called it the Upshot. And this is what, we don't have a homepage because homepages are silly in the year 2018, but this is what our section front looks like. And there's, you can see there's mostly political stories on there right now. We recently had a political election, but there are also stories about healthcare policy, about peer reviewing, about cities. Emily Badgers wrote a story about Amazon because they announced that they were going to be in New York City just today. But as we mentioned in the introduction, officially what the Upshot does is they write about politics, policy, and everyday life. Can you think of a topic of the news that does not fit in this extremely broad umbrella of content? I have a hard time thinking of that, and the answer is that it is purposely vague because what the Upshot really is a collection of journalists that David Leonhardt thought was interesting in the year 2013. So he, instead of saying like, I want to be the best place to get policy analysis, David sort of thought, well, I really like Neil Irwin, I really like Claire Miller, I like Margot Singer-Katz. Let's just get them all together and we'll figure out some other things to do. That's obviously overly reductive, but the fact is that we have lots of different kinds of reporters, and compositionally we're very different than other desks at the Times. We are, depending again how you count, between 30 and 50% people with very serious, I would say, skills in data analysis, web design, information graphics, sort of like computational new media skills rather than vis-a-vis traditional like reporting and writing skills. So I think that composition specifically is one of the reasons why I think our work is different than the work of our colleagues in other parts of the desk. I'm going to give you a couple examples of like how we think and what we think our mission is to our readers, and I hope that you get an insight into like what our process is and the sorts of work that we make. And I think there's no better place to start than with an election. One of the things that our broad missions of what to do is to turn readers into experts, particularly around extremely complex subjects. I was very heartened to hear Manish mention the New York Times Fourth Down bot, which is similar in the sense that, I don't want to talk too much about sports because you will find it boring, but lots of very difficult things that we like try to understand when we're watching sports are opaque to us, and yet the tools exist to make us as smart as any analyst, any NFL coach, if we just harness them. And I think the election is a perfect example of that. On election night, readers is a time where many of our readers who are not like news junkies tune into the news. They are curious about a very obvious question, which is like, how is the election in my neighborhood going? Is the party that I care about going to win this election or whatever? They want to be informed. But there's very little actually meaningful information that's being given to them, especially early in the night. And this is a picture of John King from CNN. He's extremely talented and smart. And the reason I'm including it is because he is an expert, and we cannot understand the map that he's showing us without his expertise. If we are only looking at this map, we are frequently left in this like anxiety-filled state of wanting to know information and yet not knowing it. We can only learn something if John King decides to tell it to us and touch it on his magic map. I'm going to give you an example of that. Most of the results that you get, especially early in the night when you're most anxious about what's going to happen, the first results come in from a state like Virginia. Virginia is a state that has its most rural counties report first, and those rural counties are overwhelmingly Republican. So if we tell you that overwhelmingly Republican, something you know is overwhelmingly Republican, votes are coming in, and 100 Republican votes are in at that county, and 10 Democratic votes are in at that county, so it's like, 100 to 10. Is it particularly helpful for us that we tell you that a Republican is winning? Why? It's not a trick question. Now, yeah, the sample size for sure, that there may be many thousands of people in that county, so maybe that might not be helpful. What's another reason? If it's a rural county where historically it's very Republican.
Not a representative sample.
Yeah, we know, it's exactly the right answer. We know that we fully expect that county to be Republican. So if you tell me that the earliest information I have for the whole state is from that place that's already Republican and we already expected it to be Republican, there's not a lot of meaningful information in that. And if I'm just looking at the results, I will get the feeling that a Republican is way ahead in the state of Virginia, when the honest answer is that a place we already know to be extremely Republican has happened to report first. creating this narrative that doesn't necessarily exist. So my colleagues Amanda Cox, Josh Katz, and Nate Cohn came up with something it's not the first time anyone's ever done this, of course, but it was one of the first times that it's ever been done by a very large media organization. And they came up with something called the New York Times Adjusted Lead, or the Upshot Adjusted Lead. We've now renamed it to like the NYT Projection or the NYT Estimate. We usually change it every year because we usually just like editors always be editing. But this is a time series of what that forecast would mean in President Obama's re-election in the state of Virginia in 2012. So early on in the night, the lead that you get from CNN or from any other results says that Republicans, so this is like from the perspective of President Obama, so plus 10 means Democrat plus 10, minus 20 means Mitt Romney plus 20. Okay, so early in the night, if all you're doing is looking at the reported lead, you are of the opinion that Mitt Romney is 20 points ahead in Virginia. In reality, because of the things that we know about the way Virginia reports its results, we know that that is not actually a very representative sample from Virginia. And so we can say, well, yes, this early result is plus 20 Republican, but we already expected it to be plus 20 Republican, or maybe it's actually plus 15 Republican, and we expected it to be plus 20 Republican, and therefore we can adjust our estimates both there and statewide to reflect that difference and tell you that we think early in the night, as soon as we get like the reported lead is minus 20 or minus 17, we think this is going to be a very close race. Even after 45 minutes, the reported lead is minus 20. We think President Obama is going to win the state. So we think applying this idea to presidential elections is a great way to demonstrate. It's not just to demonstrate how smart we are and like take pleasure in being clever. It's that we want to give you the information that you want, not who's winning the early vote in Virginia. It's who's going to win Virginia. And so we take a lot of pride in that. We think that this product is currently the best product on the internet for telling you who's going to win an election, and that you're not actually being informed by people on television most of the time. Yeah?
So when I read this as a reader, do I know that how real time is adjusted for this week?
Short answer is no. So we do, we're constantly adjusting the way that this works is we have an estimate to start the night for how every county will vote, the turnout estimate. And so every time we get results from anywhere in the country, again, this relationship is more complicated than I'm describing, but we'll slowly update our estimates accordingly. So if we get information about one county, then we're more likely to adjust our expectations for that county and for the counties that are geographically closest to it, or maybe those that are in the same state. There's some state effects or whatever, but we are adjusting them in real time. We don't necessarily have a timestamp CSV that we're putting out to the public, both because this entire show takes 4 hours, and for you to analyze all those things would probably take you 16 hours. But that part of it is not public, not because we're scared to do it, just because we have not yet done that. That's a good question. Yeah?
Did you use this in 2016 and did it predict Trump's win?
Oh my gosh, what a great question. So in 2016, raise your hand if you've seen this before. Okay, this is great. I want to do something. Hold on. Where are you, friend? Oh, there you are. I want to do something. So this process is an over time view. So my x-axis here encompasses the entire night. And tautologically, the reported lead converges with the forecast lead, right? As we get 100% of votes, it stands to reason that our forecast will merge. When this is the best case scenario where the public, you are as a reader, if you're tuning in somewhere else, you're effectively misinformed until midnight, whereas we've been correctly informing you as early as 8 p.m. So this is the long view of this, but on 2016, we altered our visualization of this slightly to maximize the amount of pixels devoted to telling you what's happening right now. And the way we did this was something called, we called it a forecast gauge, but the internet has now called it a needle, and now that is what it's called. But we believe that it is called a forecast gauge. And this is something, so I'm going to show you a video of a time lapse from 2016 election night. So this is encompassing from 9 p.m. until midnight. This took many hours, but I want us to watch this for 1 minute. We all know how this ends, but we're going to watch it.
About what time are we now?
We're about 9:30, 9 o'clock p.m., I think. They crossed at around 10. That's for your calibration purposes. This is where the internet really started to freak out a little bit. Okay, that's about a minute. It goes on for several years after this. So a time series version of that is represented right here. So this is just an overtime view of the chart that you just saw. There's no shame in it. Does anyone here hate this visualization? It's okay, we get mail like this on a daily basis. Okay, so a lot of our readers, who might not surprise you that they are like overwhelmingly liberal, or they skew liberal, I forgot that I'm being recorded right now, they really dislike it. And in a book that was published subsequently, this is a quote from my friend and boss, Amanda Cox. She says, "I think more people have seen this piece, a group project, than all of my other work combined. A real percentage of them hate it because it's the thing that told them Donald Trump would be America's next president. But that's exactly what it was supposed to do. It was dangerous and a giant leap forward in how we think about models and uncertainty." And whenever we're hesitant about whether we should like trot out this visualization again, and a huge share of our readers legitimately do hate this visualization, whether it is like on average, the answer to the question, should you do radial charts? The answer is like rounds to 0. So there's like absolutely legitimate visualization critiques of that form. But most of our readers, I think psychologists call it like transference or something, but there's a specific reason that they don't like it. But whenever we're hesitant about doing it, we go over to a different part of the internet, reddit.com/thedonald. And those readers love it. This is a GIF that they made. There's a nice GIF of President Trump at the end. There he is. Not a lot of laughs for that one. Here's a comment from one of those readers. "I really like the New York Times map website. While they are incredibly cucked, their election night coverage was incredibly robust. You could click on a state, view every county and how many precincts were in each county and how many were still yet to close. A lot of data was available, and seeing the little counter move over the whole night was sob with joy emoji." And I think it was all of those things. It was a tool that did what we wanted it to do most, which was to tell readers before they could get that information anywhere else who is going to be the next president of the United States. And I think that idea about showing uncertainty and about forecasting and about giving readers our best estimate of the future in the face of imperfect information was superior to giving them perfect information that was not actually useful to them in real life. Is there a question for that? Yeah.
I noticed this is talking about data visualization, but it strikes me that this is really a question of underlying data, not data visualization. I know this is both a discussion of the process by which you get the data as well as how you visualize that, and obviously there's a lot more uncertainty or systematic biases than were reflected in the data. We can talk about that process and what has changed going forward.
So in this case, I think you're absolutely right about this is like a product that includes like modeling and forecasting and uncertainty and statistics and all those things, but it's actually like this is a result of pure election results. So we are not, obviously we come up with turnout estimates for every county, and then every time we get new information about a county, we adjust our turnout expectations accordingly. But I think that like in terms of like biases, as the night goes on, that like bias in what our assumptions are goes to 0, like tautologically again, because we know all we're doing is taking what the vote is in a certain place, comparing it to our assumptions and comparing it to the votes of other places around it, and then we adjust them constantly. So I don't this is the part of the question where I keep talking, but I don't know if I'm like getting to the right answer. But I think that unlike other kinds of forecasts that we've made, for example, like our pre-election polls-based forecast is probably a better example of that. But I think this is something that has nothing to do with polling whatsoever, and is 100% based on election results. That was not a good answer to the question. You want?
Yeah.
Okay.
That there's sort of two issues here. One is that there's a data visualization issue where maybe because it's more real time, there's more movement that leads you to more of a certain sense of where the result's going to be as opposed to the opposite. But the second question is around the underlying methods by which you set up the analysis to say what that result should be. So there's the visualization, there's also the data analysis portion.
Yeah.
I know we've talked more about the formula a lot, but
so I definitely think like the reason that this is groundbreaking is not because of data visualization, it's because of analysis. Like I don't think there's any, if you, instead of using fancy JavaScript, if you were uploading an Excel chart to the internet once a minute, this would be just as groundbreaking in my opinion. It might not have the same like internet hatred, or it might not have the same number of like page views at the end of the day, but journalistically, I think that is the same information. Now you mentioned something that I think we actually have never done this since, and something our readers, it literally gave them anxiety, and I understand this, is that if you notice, this forecast is wobbling. This is intentional, and this is something that one reader on election night picked up because my colleague Gregor, who's a German national, used the variable for this in all caps, use jitter in all caps. And what this is it's Perlin noise, which is like, I'm actually probably the least equipped person in this room to talk about what Perlin noise is. Does anyone want to take a 20-second? Does anyone here who knows what Perlin noise is want to tell me? Because I'll embarrass myself if I try.
You can think of it as random noise.
Okay.
It's a little more structured than that.
So because this is based on like estimates, especially early in the night, we have an idea for the way the election is going to go. We get some results, and then like we're estimating what the final result will be. That is inherently an uncertain estimate. And so there's too much, in our view, there was too much certainty around, we simulate what this would be many times, and then our ultimate forecast for the win probability represents the median estimate of all of those possible estimates. But there's nothing like saying that our 50th percentile estimate is like massively better than our 51st percentile or our 49th percentile or 48th or 52. And so you can think of this, the way that we thought of this was that we were more or less using Perlin noise to like randomly sample between P45 and P55 or whatever, but it had the result of making people feel very physically uncomfortable. And the idea that it was measuring something. I think this is a valid critique of this, is that we never say we're using this to show uncertainty. We're describing it as like a hyper accurate measure of like a seismograph or something like that, and that's not what it is. The second part of your question I already forgot, but I can talk more about it. Okay. Yeah.
Maybe I can ask a related question.
Please.
I think part of what is unsettling about this is that it's a pretty big swing.
Well, we're also watching in like, every minute, okay, but go ahead.
I know, but over the course of the night, I mean, it went from one
Went
side
from,
to the
yep.
other, right? And I think one of the questions here is, how is the estimate created?
Mm-hmm.
And how should an audience, the audience doesn't know how it was created. And I think that's partly what creates some anxiety in, why was the New York Times so wrong about this initially, and what,
Yep. That's a very legitimately good question. And a student earlier today had something along those lines that I thought was very good, which is that I think it's not, okay, so let's say not that everything is always reduced to a sports analogy, but let's say your team is down by 2, and the last play of the game, they're going to kick a field goal. It's a 20-yard field goal, which has a success rate of like 99% or something. That's part of the reason they moved the field goals back to being farther away. Would you say that your team has a 50% chance of winning because he could either make it or not make it, which is like a completely reductive way that like Jack Reacher thinks about the world? Or would you say, well, we think there's a pretty good chance your team's going to win because knowing what I know about those field goals and about your kicker, and this is the NFL, that it's more likely than not that this is the outcome that's going to happen. So even though our live forecast here had absolutely nothing to do with polls, this doesn't know anything about polls and polling averages. At the beginning of the night, you have to start somewhere. So would you say that it's a service or disservice to start your night with your estimates for where you think the election is going to go? Or is it actually a disservice for you to say, maybe in the, on Earth 2 when Hillary Clinton is president, and she immediately goes from 50% to 90% in 20 seconds, did you actually do your readers a disservice by not accurately reflecting that she was the expected favorite? So I think this is something we've struggled is the wrong word, we've thought about it a lot, and we've had a few different variations to this approach in subsequent models, which I'll show you. But I think it's where you start is a difficult question, and everywhere you pick has flaws. I feel like I had one other point on this matter. Was there a question I didn't answer there?
I wonder if there are ways of communicating the model that you're using. That seems like whether it's worth doing that. Like, what's the thinking on that?
Yeah, I think so. Another legitimately, like, this is so reductive. It's a massive amount of pixels to show you one number, right? There's like, Amanda and I actually we're at a talk together, and one of our main arguments was like whether this is a simple chart, and I would say like, yes, gets none more simple than this. And she was like, you have no idea how many made up numbers are behind this chart, or like, this is like more complex than anyone can possibly understand. But on election night, at the same time, I don't think too many of our readers, the answer that they want to know is like, oh, what are your underlying estimates in Broward County? It's really just like, please just give me the information that I'm looking for. And that's something that we have to weigh as well. Yeah?
I can try maybe a different version of the same question.
Okay.
Is the curve suggests that everybody's model was wrong at the start of the night, and that was based on polling data and everything.
Correct.
So,
I mean, yes, okay.
Right, like not like you guys did bad work, it's just that the models were wrong. And at some point soon, you correct yourself and say, I have a little bit of new information that says that I'm drastically changing my view of the world. So, a common reaction would be, why do I trust you now at 8 p.m. when you just showed me that what you thought at 6 p.m. was bogus?
So Amanda someone asked this.
That's maybe the question.
Someone asked her a very similar question like this, and she had like a much wittier response than me, which is like, you're upset about the X, but another way of thinking about this is like, who are you to update your expectations in light of new information? And so like, that is precisely what it did, and the answer to the question is because the lines did not cross again after that, and so like the forecast ended up being right. We can talk a little bit, I don't have a good answer. We talked about this in the class earlier today too, which is that I still think there's like value in trying to help readers understand polls. Like a normal reader in a political year is just being inundated with polls from all over the world and all over the internet. And some of them are like rigorous, and some of them are from like an online poll from the Nose Hair Gazette, and not everybody knows the difference between A and B. And so like using them and helping you understand what's happening in an election is quoting Amanda, is like basically an honorable question. And so I think it's still valuable to say, here's how to take all of this polling information to help you contextualize the race, because you're still going to try to do that with absent those other techniques. If you're not using polls at all, then you're relying on other equally flawed sources of information, like some diner in Iowa or whatever.
Well, I think it's not really don't update your model. It's the question of, should I be expecting another swing later tonight, given that this information made a big swing? Are you expecting something else? I think that may be more of like if there were huge error bars at the beginning, and the minute you got initial really useful polling data, the error bar shrunk to nothing.
All right. So in fact, so inherent in this is a great question, and this is something that we're really I struggle to use. I don't want to use the word struggle, but something that we have learned, and we're even learning it ourselves, is that so in this number, the chance of winning, a win probability, in this particular version, uncertainty is baked into the number. If we're uncertain, the number is closer to 50. If we're certain, the number is closer to 100. But let's say I'm going to show you this page and it's going to be broken. So the other version of that that's not win probability, but it is total electoral votes, or so here, this is maybe a better answer to your question. So like statistically, these translate into win probabilities directly. And this is one reason why we have, in this year's forecast, we did not do a global House win probability. We did projected seat margin for this precise reason, which is that everybody, including us, when we see a win probability of 90%, we round up to 1. And I think even after the 2016 election, so we have, and we're going to look at this page in a minute, we did a House forecast for all 435 seats, which is like built into our overall forecast. So that you would fully expect, let's see, I'm going to get my 10% of 435 is 40. So if your model was well calibrated, you would fully expect 40 of those 435, without talking too much about like how they're correlated and like going into a class that I'm not educationally qualified to talk about. You would fully expect 10 of those to reach 90 and the other person to be the winner. But even when I heard that, I was like, that would be nuts. We can't do that. So like, I think all of us have a difficult time understanding win probability. But even these things, these little error margins, I think they're like enough in the mainstream, or I think readers sort of see those a little bit more, or maybe just because they literally take up more space and your eyeball can see that they're like one of many passes, that these tend to be a little bit safer in terms of like communicating with the mass public. But they're not any different really than win probabilities. Like a 50% win probability is highly uncertain, a 95% win probability is much more certain, a 99, and so on. Those are great questions. Yeah.
Not to keep asking questions.
Sure, that's the point.
But I have a question about the radial.
Sure,
needle.
the forecast needle.
Yeah. So it seems like the difference between like leaning and likely, like you're taking just a continuous like variable and making it discrete. So like what was the decision made there? Because if I was looking at this chart and it was still in leaning, I would feel very different than if it had just moved like a tiny bit into likely.
Yeah.
But, like my interpretation would then be very different. So like why was that?
So this is a great question. I think there's like a famous chart about, I think it was like the US Army did this, and it's like, if I told you something was definitely going to happen, and I asked like you to assign a percentage to it, and you might say 99 and you might say 98 or whatever, and then I like did this whole survey. I can bring it up later. I'm scared of live Googling, but basically is that all of us perceive these probabilities and associate them with different categories. So you're talking about like, the number here is no different, but you're absolutely right that these discrete categories mean things to people. And so one of our colleagues, Nate Cohn, and the other Nate Silver, have gotten in like several, it's almost like a joke now, but they get in Twitter fights about like, what's a toss-up? Like, what would you say is a toss-up? Tell me. What percent would you say is the range between toss-up where you're like, that's a toss-up? Is it like 49 and 51?
No.
Okay.
Maybe 65.
65 is the magic number, and ours for a toss-up. That's well done. So 65 to 35. But Nate Silver's like, that's not a toss-up. Oh, now I'm going to get which Nate said what, so I don't want to like get into the Nate wars. But like, the best answer that we have is that I think that we are using some like, I don't want to say that we're using a US Army standard, but like no, I'm serious. The US Army did like categorically come up with some of these things, like what's a safe way to describe like something that's likely to happen. But we didn't randomly assign these numbers. So I think the toss-up is very wide by definition. I think it's 35 to 65. And I think even likely, I think starts at like 85 or something. So if anything, I think we are editorially cautious on these measures. And the thing that we don't want is to be wobbling between them constantly. That is like a recipe for unease. Yeah?
I have a broader data visualization
Sure.
and sort of modeling question as well, which is, and it can be applied to this also, but how do you balance models that you can explain versus models that are most predictive? And there's obviously some balance between those two where explanatory models, like maybe you say the 80% projection that Clinton will win is based off of these combination of 6 polls, and you can explain that. Or it's some sort of black box algorithm which you can't explain but might be a little bit more accurate? How do you think of those trade-offs?
So we struggle with this a lot, particularly with the pre-election polls-based forecast, the thing that the New York Times before the 2016 election said, Hillary Clinton has an 85% chance of being president. If you're into fractions, that's like a 5 and 6. Like, I still think we're like relatively comfortable with that number. It's like, it's like whether it was really 1 in 3. Like if you ask God how many times that God simulated the election and God told you the answer, like we'll never truly know like what the actual. You could say like the answer was 100% Trump because it only happened one time. But we basically, I think, let me try to go back to your original question. We try to be as transparent as possible with the inputs and outputs. So for example, this is little solace to like 90% of readers, but our polls-based forecast was 100% open source. So anybody could download and see exactly how we're rating it, and they could run it on their own computer, and they could tweak it. We published in 2014 a version of the model where it's public-facing, sort of like an observable, and you could rate and say like, I want the poll or the forecast to be like very receptive to changes in the last 3 days, or I want it to be not so receptive, or I want it to like the states to be correlated this much rather than this much, and you could like see for yourself. So I think it's a sort of a cheap answer to say like we're as transparent as possible, because the honest answer is that most of our readers are just not going to go there. Like even I don't click like the GitHub links, But on the other hand, I think something we're really struggling with, and we argued about this for the 2018 forecast, which is like win probability as a term is just very flawed. Like it's not something that translates very naturally into English. People don't use it in everyday life. And so we're even thinking about just changing what that label means to say like, how sure are we of this forecast? Like how certain are we? And even taking like the percentage off it, just being like, we're 90 out of 100 sure or whatever. Just something that is like plain English to say, oh, well, they're not that sure or they're this sure. So it's not like, in real life, I don't think that there are tons of examples where we have like a very predictive black box algorithm versus like easy to explain highly uncertain algorithm. Like in this world, I think it's just sort of not too much more complicated than poll averaging with state effects and that sort of thing. So I don't think that we're doing anything like NASA level. So we're 0 out of 0 in like approaching that question, I think. Yeah.
Going to previous point about people being upset about the needle and
Yes.
consider. And I realize this is not a legitimate kind of criticism of needle, but is it possible that the public is really concerned about the fact that polls have been known to distort the outcome of the elections, for publishing polls? And 20 years ago, we came with this term Bradley effect. And since then, this has been analyzed kind of very rigorously that in democracy, pre-announcing the election results would really change the outcome. Is it possible that people are kind of upset, but even those who do rigorous voting, do this service by posting those?
So I don't believe that polls-based forecasts, there's a line of academic research about like people, if you think that your candidate, in fact this came out like this year, if you think that your candidate is going to win, this survey found that you'd be less likely to vote because your candidate's definitely going to win. And so like, is the answer to the question, did the New York Times make Donald Trump president? I think the answer is unequivocally no, they did not. And I think I just like, without going into like an academic war I'm ill-suited to win, I don't think that polls-based forecasts are the reason Donald Trump is president, and I don't think that the honest answer to why our readers hate the needle is because it told them Donald Trump is president. That's the answer. I think that idea is super interesting and valid, but not the answer to this specific question. Okay, we'll come back to this in a minute. I think these have been the best questions I've ever been asked about this, so I appreciate that. So the needle has made its way into like popular culture, and one downside of the asking Nate to be more interested in learning skills is that he now knows Photoshop. And so Nate has tweeted this on election day. His followers look forward to like the latest needle Photoshops. Believe it or not, there's a huge segment of nerds on the internet who really love this stuff. And it really entered the popular, for me, this is one of my favorite ones, where Emily Nussbaum, one of my favorite writers at The New Yorker, went as the Needle for Halloween this year as the scariest costume she could think of. And Jake Tapper was worried that it was going to trigger all of Brooklyn, and he was not wrong. But I think Amanda is right. It's like not a hard thing to say at a speech that your boss is right, but I think it really was a step forward in communicating models and uncertainty at a very newsworthy time with, and it was incredibly dangerous is her word, but I think it was very different, and that sort of approach has been embraced in other aspects of our report, I think, to positive net effect. Yeah?
I actually wanted to ask the question earlier. Why did she use the word dangerous?
I don't know, because she's like 100 times smarter than me, and so she knows something about what she's saying that I don't. But I think...
I was curious when you said that for the first time, why it was...
So I'm just quoting Amanda, but I think it is dangerous in the sense that, like, it's audacious to tell you that Donald Trump, like, it's not, the New York Times is not making race calls, but I think it's definitely audacious to say, we're going to tell you who's going to be president before anybody else. And I think it's dangerous by definition in the sense that it's high risk that if it went from 95 Trump and then it went back to 95 Clinton, like, they would have fired everybody, you know? So, like, I think it is dangerous in that, like, employment sense.
Because there were a lot of other New York Times things, like the day before the election, saying that this is the chance that he's going to win, too.
Sure.
You weren't the only source at the New York Times.
On election night in real time, we were the only source on the internet.
That's what they're doing.
Yes. So specifically, we're talking about the polls-based forecast. I think actually it would have been more dangerous for us in that, like, competitive news environment to not have a live forecast, or I'm sorry, not have a polls-based forecast, because, like, from a competitive space, like, it was sort of a commodity in the year 2016. Everybody had one of those, yeah.
So you're saying it was dangerous and that you were making...
The live forecast is dangerous, yes. This is what it looked like in 2018 on election night just last week. And this is the reason I couldn't come here until today, is because I was not allowed to leave my desk until this was published. But this was a night that went much like the night in 2016 was expected to go. And so here is approximate seat composition over time. And so going back to your earlier question about 50-50, would we be doing you a disservice if we started both of these at 216.5 seats or whatever it is equally, or is it better for us to start with our best estimate and just adjust it as the night goes on? In this case, a flat model is a happy model, and so this is the sort of thing that keeps our pulse as low as possible.
Question.
Yep.
So you've got data from last week, and you have data down to the county. We have outstanding races still.
Yep.
Does Upshot have projections relative to those outstanding?
Yep. So we turned this off on, so the primary goal of this is to tell you which party is going to win the House. And so we turned this off at 2 o'clock, but lots of these things, in fact, including in Florida, our estimates were pretty good there about, if we didn't know that there was going to be a 20,000 undervote in Broward County. We actually did a map about that last week that was, I think, quite good. But we still have, like, those outstanding votes, we still have estimates for them. We still give you our best idea about who's going to win in those places. But we weren't, this isn't a tool to tell you who's going to win a recount. And especially, so it is based on counties, but it was also it was wired to be based on precincts in a select number of places. And part of the reason we went up with this a little bit later than we wanted is because those precincts, I think Clarity changed their website in Kentucky 6 at the last minute, which of course they did. And so at the end of the night, we were forced to go back to counties. But we are wired and ready to accept precincts if only our country would adopt federal standards for those things. But that is an entirely different lecture that I would love to give another time. These are all like examples from the world of politics, and this is something that's like dominated my life in the last like 3 weeks, but I think, I'm sorry, 3 months. But it is only a part of what we do, and I think our most inspired work, or the work that we're best known for, I think even this is outstanding work in my view, but it's also work that is increasingly commodified. Or even if we have the best product on the internet, if you just went to bed that night and you wake up the next morning and someone tells you who's going to win the House, then like our best case scenario is informing you 30 to 40 to 2 hours before the like election is called. So like our competitive advantage is like 2 hours of internet time. So like increasingly, this is, I think, again, it's a noble cause to give readers information they want to know as fast as possible, but at the same time, this is information that will absolutely be known 24 hours later, so like there's a diminishing returns to your effort on this sort of thing. But I think there are other projects that we do that have nothing to do with elections or that involve unearthing new information that demonstrate a lot of value. Something that we're, I think, quite good at is identifying and leveraging data with journalistic value. Around the fall of last year, my brother sent me an email, my older brother Sean, and he was asking me, he was about to run the Boston Marathon. He was asking me if he should buy a pair of shoes that would make him faster. And I thought this was in line with the question that I had been wondering about for a long time, which is, why is my brother faster than me? He's there in the middle in the red tank top, and he's my older brother. He just turned 39 like 2 days ago. And it's really annoying that he's consistently and increasingly faster than me at running. And he was asking these questions about shoes, and I was like, maybe it is Sean's shoes that are making him faster than me. This is a basic journalistic question that people without data skills or people who are more traditional reporters have tried to cover for a long time. One of my idols at the New York Times, Jerry Longman, wrote a story last year. This is in 2016. This is a picture from the Olympics. And the headline of the story is, "Do Nike's new shoes give runners an unfair advantage?" And the color's not very good on these, but these are actually like bright neon shoes, and they're all wearing them. Like not every person, but all the people who are winning the races are wearing them. And this is Eliud Kipchoge. He just set the world record in the marathon. And he's sponsored by Nike, of course, who's wearing these shoes. And again, this is one of the New York Times' finest journalists trying to answer this question, but it's not clear how to answer this question with the traditional journalistic tools that you have. He's extremely well sourced in the running community. He's talking to like running coaches. He put me in touch with the race director of the world marathon majors. That was cool for me. He's like, oh yeah, just call him. He's on vacation, but tell him I sent you. But this is just asking experts and saying, do you think this shoe makes you faster? And some people say yes, and some people say no. And it's like sort of not easy to understand. But there are places on the internet where you could answer this question. And this is data that's on the internet. Does anyone here use Strava? I'm a big Strava user. And this is Sean's. This is like a morning jog that my brother Sean took earlier this week. This is public on the internet, but it is a map of Prospect Park in Brooklyn. And I know this because I use this app all the time, that up in this little right-hand corner on his little race report is his self-reported shoes, Asics Cumulus 19 White 2. And he wrote that in himself, and it has a little estimate in there for how many miles he's run. Runners use this because they run a lot and they need to change their shoes after like 500 miles, and it's nice to have a computer tell you when to get new shoes. So I thought, is this information, is there a way that I could find out if shoes, if I can find out if people are racing more in their shoes? Obviously, what my brother did on a training run on a Monday is not helpful to me. But people who use Strava are very enthusiastic. That is an understatement, I think. They're so enthusiastic about running that they upload all of their runs to the internet and make it public. The internet does not care where Sean Quealy lives, but he's uploaded it every day for the last 5 years. And on race day, runners are even more enthusiastic. About 1 in 4 runners of the New York Marathon uploaded their results to Strava publicly. 1 in 4. Maybe 1 in 5, but that number is astonishing. So what we were able to do is, if I have a list of races like this, here's all the races. Strava, they have a little flag for what's a race. So here's all the races that exist in the last month. You can find a master list. If I click one of those races, I find a list of finishers. Look, 165. I can just page through the results. And every one of these races has a finisher with a profile. And here I can find out that Nick, oh man, it always does this. That Nick A, who says he had a tough day while running a 2:22, boo-hoo. He was wearing the Under Armour slingshot. And so I can assemble a massive database, depending on whatever you think of is massive, for marathons and shoes. And what else do I have in here? I have the date. I have what race it was. I have this runner's name, and I can go back to this runner and find out his or her age and gender. And I could basically create a database that says, like, it allows me to at least try to answer this question. And because there's no way that my brother is faster than me, I thought this was a very good use of New York Times resources. And this is the data that I was able to compile just for Sean. This is what it looks like for every Strava athlete who's run in a race in the last 3 years, which ended up being about 500,000 completed races over the last 2 years, marathons and half marathons in every continent. And it has a name, a gender, a cleaned version of the shoe. For those of you who do data cleaning, this is like it's like one of the most enjoyable activities known to man, because people write this in themselves, right? This is like people literally spelled Vaporfly 100 ways, and I got them all. You know, it was so exciting. Like put the headphones on, like leave me alone. And then all the races, the race type, the race time. I'm obliged to say that Sean got a 2:47 in New York this year. He made me mention that to you. Their age and some like weather events, like, because I know where the race was located, I know what the temperature was. I can find out from weather data, like if there was rain or hilly. I can also find out metadata about the race, how many turns it had, what the elevation change was, and so on. And you can basically use this data to, again, answer the same question that one of my idols, Dree Longman, wrote about in 2016, but you can actually answer the question somewhat structurally. So if you all had this data, even if you're not an expert in data statistics, what's a way that you could find out whether this was true or false? Or we could begin to answer a question like this. If I told you, yeah, go ahead.
Make a graph.
Make a graph. I make graphs for a living, so that's always the right answer. More specifically.
Maybe you could just make so maybe you could maybe just make some kind of like line plot. So you can make, or perhaps maybe a bar graph to make kind of there's a correlation.
So correlation is a really good idea. Even without like getting too narrow into forms, like what would be evidence if I found out that a bunch of Olympians or people who are running at Olympic speed were wearing these shoes? Does that mean, would that convince you? Like if we were in a bar, I was like, but all these Olympians are wearing these shoes. Would you find that convincing? No. Okay, so what would be more specific? What would be, go ahead.
The runner's average mile pace when they're wearing a different shoes and their average mile pace when they're wearing that shoe.
Yeah, so I think going back to that's a really good way to think about that. And because of what we know, which is that these runners are quite enthusiastic, there are about 1 in 5 had uploaded a race for more than one marathon, and I think it was something like, I'm making this number up, but it was something like 1 in 8 had uploaded for 3 or more. So we can follow athletes as they run their course of their like running history in our data, and crucially, we can follow them as they switch shoes. So we can answer questions just like that. That's one very good way to do that. What's another one? Yeah. Yeah.
I did something very, very similar to this a number of years ago. And the problem is that the effects of weather, humidity, and elevation within different races
Yes.
are much greater than any effect due to the shoe.
That's true. Any runners here? So like if I told you that like last year I ran the Boston Marathon and it was like 40 degrees and it was sleeting the entire time, and then in my case I ran the Providence Marathon, it was a beautiful day and as flat as a pancake, like do the shoes matter? That's not like not really like a first order variable. Okay, so one of the ways we can account for that, or to at least acknowledging that, especially in a race like marathons, they're so different and weather matters so much, and like maybe you had bad spaghetti last night and that has nothing to do with your shoes and you had a terrible race or whatever. We can do things like a technique called match pairs, which is to say, if we ran a race together and we don't even know each other last year, and we ran the same race this year, or you and I happened to run 2 races together, and one of us switched shoes and the other didn't. If I improved my time more than you improved your time, and I switched shoes and you didn't, in aggregate, all of those match pairs for that race, we can start to compare shoe switchers to non-shoe switchers. That's like one of the most sophisticated techniques that we did. And again, there's no like cut and dry perfect way to answer this question. But this was more of like a data exploration where we said, there's no way we can know for sure, but here are 4 ways. Every way we looked for this question, we found an answer. So one was, this is the result of that product. Nike says it's $250, shoes will make you faster. What if that's actually true? And we found that it was true. We found that people wearing these shoes, no matter where we looked, tended to run 1 or 2% faster than people with, or than the next fastest shoe, and about 4% faster than people with wearing an average shoe. Now, 1% might not sound like much, but laser suits in the swimming pool were banned, and they were said to have increased speeds by 1 to 2%. And so the answer to the question of like, do we believe that someone who's wearing the shoe has an advantage over someone who's not wearing the shoe? We think the data says absolutely yes. So here's an example. Oh, so actually, that's a picture of my brother Sean right there. It's just a coincidence. I was looking for 3 people who finished New York Marathon in 3 hours, and I know that Ben did, and it turns out Ben ran with Sean, and that's why Sean's picture's in there. But basically, everywhere we look for it, shoe switchers, we see charts like this, Vaporflies at the top. Or if we see people who compare shoes who are the same group races. So these two guys don't even know each other, but they finished at the exact, like 10 seconds apart in Boston in 2017. A year later, Mario switched shoes and Tony didn't. And again, neither of them says shoes mattered in this specific race. But on average, when we have hundreds of shoe switchers and hundreds of match pair races, in aggregate, comparing those results, we found that people who switched shoes changed their time, improved their times much more than people who did not. Yeah.
Do you condition on any variables to see, like for example, maybe people with higher income will be able to afford $160 shoes, but also the people with higher income will be able to afford better trainers? So
Sure. So the first answer is that everybody who's running the marathon is high income. No, yeah, we acknowledge that there's a million variables that go into this, and we can never account for all of them. But even things where we can account for things, like if I had a database of everybody's income, I would definitely use it in this thing. We don't believe that it would matter that much. And secondly, we did account for some things like training miles. So if like I know how much, and that didn't tend to matter so much either. And anybody who here who's like raced knows that your time, like the best predictor of what your race time will be is what your last race time will be, not how many training miles that you've done so far. So like wherever possible, we gathered data from other sources. The weather was most important among them, but also training volume, and they didn't have much of an effect. Anyway, I mean, I could talk about this all day, and I in fact do talk about this a lot with anyone who will listen, but I think this is a good example of the kind of analysis people with data skills and an inquisitive mind. This is like, there's nothing advanced about this question. We've written about this several times, but it's the approach that is different in this newsroom, and the like ability. This data has been in plain sight for years. It's just knowing that it's there and knowing how to get it and how to ask the right questions from it is something that we hope more journalists will be able to do in the future. That's people like you. And we do this for all sorts of news questions. One is a very basic, not even serious question, but it's something that New York Yankees fans and Boston Red Sox fans ask a lot, which is that where do Yankees fans turn in as you go north in New England? Where do they magically turn into Boston Red Sox fans? That's not a question that is going to win anyone a Pulitzer Prize, but it is something that people talk about. In 2006, the New York Times sent John Branch, one of our finest journalists, to literally drive around New England and find out the answer. This is a map that he created after his driving. It's labeled the possible border between Red Sox Nation and Yankees country. I think this is a fantastic map, and I think this is a great article, and there's absolutely nothing wrong with it. It's a very traditional approach to answering this question. It's based on dozens and dozens of in-person interviews, shoe leather reporting, and driving around to bars and asking people. That's great, but and again, I love this map, but there are also other ways to answer this question. And we thought, not only can we answer this in a more structured way, because maybe if John went to bar X instead of bar Y, the map would be a little bit different, but can we also do it at scale? So not just for Boston Red Sox and New York Yankees, but for every baseball team in the country. And we knew that it's imperfect, but people do register their fan support at scale on Facebook. Again, Facebook's data is absolutely imperfect, but it is yet another source of information, and we were able to make something like this. And you know what? It looks pretty similar. One big difference is that I meant to like georeference this, but John Branch was under the opinion that Hartford was Red Sox town and Red Sox place, and Facebook says it belongs to the Yankees. But we're also able to do it for everywhere. Again, this is not like investigative journalism at all. Okay, this is not going to save any lives or get anyone out of jail, but it is a question that normal readers have, and part of our like goal is to explain the world, and we also like sports, and sometimes we do silly projects, and so like this is just as honorable of an approach as driving around New England. It's just a different way to think about it. Is this unequivocally the truth? Absolutely not. It has flaws in the same way that John Branch's version of driving around New England has flaws. But it is absent like God emailing you a CSV for every zip code. It's not bad, we think. And it's consistent with other like ways we have of analyzing this question. And so this sort of thing, I think, is something that we do relatively well. Yeah.
How do you get access to the data for something like this? You know, Facebook is tighter and tighter about it.
I thought they were like a company super well known for transparency. This is where, this is not the most useful answer, but it does help to have your email address end with nytimes.com versus like, you know, blogspot.com. But this was a long time ago, and they don't necessarily give us the same level of information, but they also, you know, they did basic things. Their data science team is very good, and they gave us zip code level information, but they didn't share any actual numbers. So there's absolutely no, we don't know anything about any individual user, so it's totally aggregate information. And then we also did spatial smoothing on this to basically like, in a very rural area, if there's no data for a certain zip code, but all the other areas around it are a zip code, we think it's safe to say that this place also likes the Twins, even though no one is logging in on Facebook there. So we literally altered this data from what they gave us. But obtaining information is easier when you work at the New York Times. Yeah, that's the honest answer. Okay, the last example I want to show you is about how we experiment with form. I think one of the, probably sketching with data and experimenting with form, I think, are the things that define us most. And I think we do that because we are compositionally different than any other desk at the New York Times and most other news organizations. We are only 11 people at the Upshot total, and depending on how you count, between 4 and 6 of them have serious skills in data visualization, web development, data analysis, the other assorted PDF, assorted digital skills, and that allows us to approach the news more creatively and more from a more sophisticated technological perspective. And the example that I'm going to show you is a very boring one, and it's the quality of the work, I think, is because the original chart was so boring. So Raj Chetty and his team of, poor his team, there's like 10 mega smart PhDs, but it's always like Raj Chetty and others. But he used to be at Stanford, and I think he recently went back to Harvard. But their research is about equality of opportunity, and their like research trick is that they linked kids and parents so they can answer questions, and like they know how much money your parents made, they know how much money you make, they know where you lived when you were a kid, and they know where you live now, so they can answer questions like, how likely is it that a poor kid becomes a rich adult in America? That's like the basic foundation of their research. And it's very good. And income mobility is not very good, but their research is very good. And one of the subsequent analyses that they did is they were able to link this relationship to all sorts of other factors, like what's the likelihood that you get married depending on what college you go to, or what's the likelihood that you go to college based on your parents' family income. And Amanda had made this chart on her computer, and she loved it, and she thought it was mind-blowing, but she thought that it was so boring that no one would ever be impressed by it. So instead of showing you the chart, we thought it would be cool if readers drew it themselves. So the specific topic I'm talking about is about the chance that you go to college. How does that chance change depending on how wealthy the family in the United States you grew up in is? So this is a scatter plot. On the x-axis is your parents' family income. So this is like the poorest family in America in family income. This is like the richest family in America. And then this is how likely it is that you attended as an adult at least 1 year of postgraduate of college. We want you as a user to draw this chart for us. We'll give you a free tip. For the median family in the United States, 58% of kids born into the median family income, an average income household, 58% of those will at least go to 1 year of college or more. What's the general shape of this chart, do you think? I see like the general, like most common chart form up and to the right. Why is that? Why is that like your default? It's okay to have a stereotypical answer without listing the stereotype. Yeah?
People who are born to wealthier families generally can afford college.
Yeah, that makes tons of sense. It's like if your family can afford to send you to college, if college is very expensive, it makes more sense that rich kids from rich families would go at higher rates than kids from poor families. Now, knowing that we know that, do we think that the cap 100% of rich kids will go to college and 0% of poor kids will go to college? No. What about the general shape of this chart? Like what I see like some shapes.
Suspect that it's concave up.
Concave up? Okay, so I'm going to start drawing and then I want to hear if people think that I'm like this. Well, we know this goes through the line, so I got to be honest. Okay, so we know that is this hump real? Am I just doing a bad job drawing? So it's like a snake? Are the levels okay? Do you think 30 is about right for poorest and 80 is about right for richest? Down? Wait, which way is, what's the down? America is worse for poor. Okay, here, like this. And then what about rich people? Higher? So like, is it like a level, like you attain a level like this? Or is it like a straight line?
Drops at the end.
Well, why does it drop at the end? Why? It's okay, we're all thinking it, just say it. Because rich kids, sometimes you're so rich you don't need to go to college?
Yeah.
Okay. See, it's so freeing to say it out loud, isn't it? Okay. Is anything else? Is this like we think generally right? Okay, Amanda calls this part over here the trust fund bump. Okay, and she also says, you all passed, she says, smart people draw an S, and for the exact right reason. So that you think beyond some level, no amount of money is enough to send you to college, so like it maybe flattens out on one end, and then above some perhaps arbitrary threshold, there's no like making $150,000 a year versus making $160 doesn't appreciably change. Like at some point you can just afford college. And so she thought this exercise was so interesting that if she just told you the answer, you would never get it. And the funny part is that we are completely wrong in this guess. The answer is literally a line. And that every percentile your family is richer, it moves your chance of going up to college the same linear percentile, or the linear percentage. These are not model outputs, these are observations from tens of millions of Americans. So if your parents' income moves from P90 to 91, that's the same increase in your likelihood of going to college as it is from your parents going from P2 to P3. And she thought that was just crazy, but that if she just gave you a chart of a straight line, it would never really resonate. And we also are able to do fun things like sketch this, which is the aggregate of how every other New York Times reader has answered. So in general, like this sort of experimenting with form is something that if you don't have this compositional like group of people with these skills, we don't think that you're going to be able to produce journalism like this. So I can talk forever, and I have other examples, but basically that's where I would end it for now. And if you have any other questions, I'm happy to talk until the end of time. Yeah?
I'm curious if you have this for other countries.
For other countries, no. So there have been some replications of the Chetty research, and they have replicated basically their original finding, which is like we call it like the hockey stick, which is that some places really do matter more than others. So it's like if you move from a bad place to a good place, and you're young and you have like an older brother or sister, if you move from a bad place to a good place, you will improve more than your older sibling just by being there that extra amount of years, which is crazy. Yeah.
How do you make the decision of, let's say, featuring Chetty's research, which had incredible amounts of data, versus other economists who, also have lots of research findings and data points as well?
We get this question a lot from those other economists. There's not a, so he, for better or worse, we think that, so one is that this specifically about Professor Chetty's research, and again, Nathaniel Hendren and the whole team, their scope is just simply bigger. This is not a survey. This is not a natural experiment. They have the tax records of all of us, literally like everybody, and so they are like telling you what actually happened across millions of like intergenerational mobility in the United States. So I'm sure someone will find me on Twitter and say that I'm completely wrong, but we don't get that kind of scope of research too often. But also Professor Chetty is like this is a compliment to him, he's very well versed in like working with the media. He's, he's just more savvy than lots of other folks. I feel like I should stop talking because I'm on camera right now. But that is probably, so the main reason I think is that we think that this is just a story that we don't find in too much other research. But it's true that we are inundated with, like we read the NBR papers as they come out every week, and we're looking at journals and the like, and it's true that lots of professors of economics would like it if the New York Times wrote about their research as much as we write about Professor Chetty's. And I think there's a serious and correct criticism of the Upshot that we probably write about his research too much. Yeah?
Kind of on a related note, how do you, you're pulling data from all these different places to write these things, and unlike your colleague that you showed the example from, who's talking to, the 5 experts on whatever it is he's writing, they're writing about, how do you know you have data that is true? And how do you feel about reporting that without actually asking someone who is an expert in that particular domain?
So that's a really good question, and the answer is that we don't. And we don't just find a data set on the internet and publish articles in the New York Times based on that data set. For every, this is a separate case because it happens to be information that we believe is literally true because it's from the IRS. But if it's something that we've gathered ourselves, whether it's a finding that we found based on Strava data, or even this baseball fan map, again, which I can't emphasize enough is not going to save the universe. Before publishing this, we do say, well, is this consistent with other sources of information? If I wanted to find out this question, what other sources of information are there? So there are some limited polls of especially the New York Times sports desk, not wrongly, was very skeptical that no place in New York City are the Mets preferred to the Yankees, even at Citi Field. The mostly Queens-based sports desk was not thrilled to see that. And that's an absolutely correct criticism that's based on years of domain knowledge rather than some CSV I downloaded from some teenagers in Palo Alto. So, but we did find some polls where New Yorkers were asked, and to the best of our knowledge, this information is consistent with those things. And wherever there's a discrepancy, we usually will highlight it. And even with our Strava data, we talked to dozens of experts. We talked to the director of the World Marathon Majors. We talked to people from Nike and other shoe companies. We talked to people from Strava. We definitely, this is one source of information, and it's not the only source of information. And so we would apply the same standards and critiques that we would to this as to any other form of journalism. So you're absolutely right that the biggest kind of miss is that to paraphrase Donald Rumsfeld, when we don't know what we don't know, and so when all of our things check out, but maybe for all we know we're publishing something that is completely wrong. But that's a risk no matter what your source is in journalism. It's a really good question. Anything else? Okay, well, I'll be here if you have any other questions. And thanks for, anything else? Oh,
not for me, but thank you.
Thanks for your time, guys.